Welcome to our latest edition of the Far Out Journal Club. This is produced by Rich Russin and with technical support from James Albury, the planetarium director at Kika Silva Pla, and also some video support from Matt Peters. I'm your host, Terry Smiljanich. Now, the Far Out Journal Club is a semi-regular feature of the Alachua Astronomy Club, which is located here in Gainesville, Florida. We are joined tonight by members of the Howard Astronomical League in Maryland and some members from the Tucson Amateur Astronomy Association, sponsors of the Grand Canyon Star Party out in Arizona. The goal of our club, of this club, is to have a personal, in-depth visit with the authors, artists, musicians, curators, and other cultural icons who bring us the vast world of cultural science and science fiction. We've had as our guests Joe Haldeman, who was named by his peers a Grandmaster of Science Fiction, Tim Russ, a leading actor in the Star Trek series, our own planetarium director here, James Albury, Yerkes Observatory director, Dennis Coes, astronomer and best-selling author Emily Levesque, and last time, esteemed author Davis Sobel. It is our pleasure tonight to have as our guest James Traile. Now, James is an award-winning filmmaker and is a planetary science producer and animator for the Goddard Space Flight Center in Maryland. He has studied, he studied geosciences at Princeton and has spent most of his career working on the intersection of science, science and art to produce videos and documentary presentations for television, YouTube, and NASA's social network or social streaming capabilities. His award-winning videos have appeared on Amazon Prime, PBS, Hulu, and many other streaming services. His works have been featured at film festivals around the world, and he started very young as a student filmmaker and was invited by the White House to meet with President Obama as part of the White House student film feature. He's had, as I understand it, over 200 million views of his various productions. And as a live host for NASA on some launches, I believe he had as many as 10 million viewers at one point. So he's well known for producing and presenting these visual exemplars of science. James exemplifies the goals of the Far Out Journal Club, which of course wants to feature guests whose work are at the intersection of astronomy and art, of science and culture, helping to bring the wonders of space to non-scientists. And that actually is a good job description for what James Traile does. So James, welcome to our club and thank you for being our guest.
Yeah, thank you for having me here. It's cool to be on here. Really enjoying chatting about all this stuff and excited to share some of my work.
Okay, great. Well, now let's start off with something. As a filmmaker, you're always behind the lens. Now you're in front of the lens, and you're being interviewed as opposed to being the interviewer. I'm sure it's happened before, but it must be a strange feeling for you.
Yeah, it's surprisingly not too bad just because I've hosted quite a few of our broadcasts, and in college too, I had a bit of a theater background too. I somehow got roped into doing French theater in addition to the science work that I was doing. So I got a little bit more comfortable being in front of the camera, being on stage, presenting things, and it's helped a lot now with the work I do. Kind of understanding, I guess, both perspectives as you work through and make these things, bring the science to life.
Now, when you conduct an interview for one of your productions, how do you approach the interview? What are you trying to accomplish with the interview? What are some of the tricks of the trade you use to get the people to open up?
Yeah, you kind of treat it like a conversation. I think you want it as much as possible to feel like it's just you and the person, not the cameras, not the lights, not the whole crazy stage setup filming them. it's just a dialogue with them. And I think one of the worst things to do is send your questions ahead of time, because people often get a little bit too rehearsed. They'll kind of plan out certain answers, and then as they're answering the questions, if they don't answer it exactly how they intended, down to the exact wording that they wanted to use, it can just totally throw them off the rhythm and really mess with them. And, it takes them a while to kind of get into a natural flow. And so I almost just kind of just prime them before the cameras even start rolling, just start chatting, opening them up, talking about the work they've done, connecting with them. And it just really gets people so excited to talk about the work they do, and they kind of forget the camera's even there. I just keep it running. I don't stop between questions or takes. I just kind of keep it going and just keep it natural and this natural flow. And I've had interviews that'll last a couple hours long, because just the science that we're talking about is just so fascinating. The people just are, it's infectious energy, and you just keep it rolling. And it really shows once you get to the final editing for these films. Just that passion really shines through when you're talking with people. I think it's always super helpful to research ahead of time as well. Obviously, I have a science background, so I always like to dig into the primary sources that the scientists are putting together to really understand what they're doing, so I can ask educated questions. Oftentimes, I will prepare kind of a preliminary list of questions I want to address and that are important for me to hit as I go through the interview, but stuff will often come up, and really almost always comes up, that I'm like, that is an interesting thing I didn't think about. Let's pursue that a bit further. I ask a ton of follow-up questions, and I lead to these amazing answers that I just never expected in the first place. And we have just a fantastic dialogue going.
Yeah. Well, as you point out, if you follow a script, you're not really listening to the answers. You're looking at your next question. And really a good conversation is a back and forth, a real time back and forth. Now, when you're putting your video together, there's going to be one person at the other side watching it. Only one person at a time is watching it. Do you try to envision who that person is, and who you want to talk to?
Yeah, so for NASA, all of our videos, we try to approach at an eighth grade comprehension level for science and for academics, to make sure that it's not dumbed down in any way. It's, educated enough that it really makes sense. And so that's, I guess, kind of the target audience we're going for, but every single product's different. And so I've done anything from kids kind of cartoons to inspire the next generation of scientists, all the way up to more advanced, very technical kind of infographic mission proposals for a lot of the stuff we do. So I always do kind of have a rough understanding of our audience, but this work is for everyone. We want to make sure that the science is approachable, it gets people engaged, and everyone resonates with different things with what we present. I want to make sure that we can meet everyone's expectations of what's going on here, and everyone will take something different away. Sometimes it's a spiritual thing, sometimes it's a, more scientific thing, sometimes it's more of an artistic thing that they're taking away from the work we put out, the imagery that we release, these animations, the visualizations. And so I always kind of keep that in the back of my head as I'm working through, just to make sure that I kind of have a rough idea. But every project is different, which keeps it exciting, keeps us on our toes.
Yeah. Well, we're going to get into some of your specific shows that we can all share. But let me ask you first, when you were getting started off, did you have any particular people who inspired you to do what you're doing?
Oh, absolutely. Yeah. I mean, when I was growing up, I was a big fan of Bill Nye, the Science Guy, of course. That was kind of one of my first inspirations, watching his show, and just the energy that he brought to teaching science. I was really into the cosmos, both the more recent Neil deGrasse Tyson version and also the older Carl Sagan version. And then also some cartoons too that really inspired me. I was a big PBS Kids fan growing up. Cyber Chase was one of my favorite shows, and the way they were able to distill, not maybe the most complex science or math, but still nonetheless some really exciting science. They would be able to portray in a really exciting, engaging way and get me excited as a, 6, 7 year old, learning this stuff, getting engaged and figuring things out. It was really kind of foundational for me as I was going along. And, I still look up to these people as inspiration as I'm making my content. I think, I'm always trying to find new inspiration from a lot of artwork and things around me as I'm designing things. And just the way people approach storytelling to me is always fascinating. I've taken inspiration from some kind of strange places at times too. For the most recent film I put together, I was really heavily inspired by Moneyball, the way they kind of structured a lot of the technical details of baseball. I'm a big baseball fan. But the way they kind of crafted some of the metrics, sabermetrics, and all these different things to make it approachable still is fascinating to me. And I try to bring that energy too, also to the work I do for NASA and kind of designing some of that stuff out.
Well, we're from a different generation, but when I was your little kid, your age, uh, back in the 50s, there was a TV show called Watch Mr. Wizard.
Oh,
That I
yes.
don't,
Yeah. I'm familiar.
and I
Yeah,
mean,
yeah.
a great show for kids because you had this guy and he would just have two kids come in and he'd do science experiments right there for TV, and it was you got inspired for science for things like that. So yeah, different generations, different inspirations. Now, when you got started, I see there's this company called AdNet, AdNet
Yes.
Systems. How does that relate to how you started or what you're doing now?
Yeah, so I was brought in as a contractor. I still work as a contractor under a different contract now, but they were the one who initially brought me in. I'm badged at NASA, so my main center is Goddard Space Flight Center, but I do actually go to quite a few different centers. The denim shirt I'm wearing here is for one of our sister facilities, the White Sands Test Facility out in New Mexico. I was there a couple of years ago working with them as they were testing some shielding for a spacecraft. They have this hypervelocity chamber. It's this massive gun that's the size of a building, and you have to go 10 feet underground in a steel reinforced bunker every single time they do their tests, and it's on the scale of microseconds. It's so quick. So they have these high speed cameras that they take pictures of the test as it's taking place. But yeah, so I've worked with a couple different contractors over the year. That's kind of mainly who's employed at Goddard. We do have a couple civil servants, but most of the producers on staff are all contractors from various different, mainly defense and aerospace contractors.
Well, you got to work at one of the coolest places on Earth, the Goddard Space Flight Center there in Maryland. What's that like?
Oh my gosh, it's incredible. I didn't know this job existed in the first place. I mean, I think I'd always wanted to be a professor or do research, and I didn't realize you can kind of combine film and science. And this is the place to be. I mean, there's amazing labs all over our campus, and I get to be there as these scientists are making their discoveries in real time and film them. We often will have astronauts come through. You know, some actually started at NASA. We had a couple kind of, or at Goddard rather, who now are on into the Artemis NASA astronaut program too. And so just the work that's going on. We've got an incredible clean room. Actually, as we speak, there's the Roman telescope that's wrapping up assembly in our clean room. I got to visit that a couple weeks ago and see that up close. It's just surreal, otherworldly to see these things that are going to be launched into space and just the brightest minds. I mean, we've got some incredible work that's going on. I work a lot with our astrobiology lab too, which I was always looking at really cool things. They recently got a shipment of samples from the Apollo program that hadn't been opened for more than 50 years. They were frozen, set aside 50 years ago. They just thawed them out, warmed them up, did some incredible work with them. And then similarly, OSIRIS-REx delivered some samples from Bennu. I was actually there in the desert covering that live for one of our NASA Live broadcasts. And some of those samples were recently delivered to Goddard too. And our scientists were looking at them up close. And it's kind of these pinch me moments on a daily basis. I'm like, what's the new thing that's going on today? What incredible science is happening? And it's every single day, it's something new. And I'm just
Yeah.
constantly inspired by the work that's going on.
Yeah. Briefly, tell us in the NASA family, what is Goddard's specific mission?
Yeah, so Goddard is the oldest NASA facility that was started in right after NASA was made into an agency in the late 50s. And so it's a big kind of college campus type thing. We've got about 10,000 employees that work there. And it's, the hub for a couple of things. Importantly, it's the hub for the Hubble Space Telescope. We have our Mission Operations Center that runs there in one of our buildings right on campus. We've got a number of labs that work for a variety of different purposes. We've got all four of NASA's disciplines there: heliophysics, earth science, astrophysics, and what I cover, planetary science. And so we've got scientists badged to all those different missions, designing things, pitching new mission proposals. We've got our big clean room there. There's a lot of work that goes on. And then we also, kind of adjacent to us, run through Goddard still. We've got a bunch of these sister facilities. There's one out in Wallops Island. That's our Wallops test and flight facility. We'll often have resupply missions that'll go up to the ISS from there. We've got the White Sands facility, as I mentioned, that's also part of Goddard. There's also up in New York, the Goddard Institute for Space Studies that's affiliated with Columbia University. So there's a lot of work that goes on there, doing a little bit more kind of computational science. But yeah, there's a whole ecosystem, and we work very closely with a lot of different NASA centers too. I often go down to Johnson Space Center, Kennedy Space Center for launches. We've got folks out in Armstrong in California, doing more of the flight dynamics. So it's a cool place to be, and we're kind of the hub of everything. And we're not too far from headquarters in DC, so we're often kind of working very closely with them as missions are getting going.
Okay. Well, let's talk about some of your specific productions. Let's start with the one that we featured in our promotion for this, Cosmic Dawn.
Sure.
First of all, some of your documentaries or videos are, like 5, 10, 20 minutes, very, very specifically focused. This one, Cosmic Dawn, is over an hour and a half long. Is it one of the longest videos you've put together like that?
Oh, absolutely. Yeah, I've done one other feature film for the OSIRIS-REx mission last year called To an Asteroid and Back, all about the proposal of that mission and the ultimate execution of it, bringing that sample back to Utah. But this one was a beast of a production. I mean, it was 20 to 30 years of content that had been filmed before I was even born. Around this time last year, about 850 terabytes of footage, interviews, animations was dropped on my desk, and I was given the instruction to make it into a production. I pitched it as a feature film because I felt like that would be the most complete way to tell this incredible story from start to finish, have you just in one sitting sit there and experience this whirlwind of a journey to get the telescope in operation and bring back some of this incredible imagery that we're seeing on a daily basis. And it was a huge production. I did all the original music for it. I was the lead editor for it, did all the sound design, the sound effects. So if you do get a chance to watch it, which I highly encourage you to, make sure you're wearing really good headphones or you're using really good surround sound speakers. It's been screening a lot of different places. Actually, just yesterday we were screening it for Congress, and last weekend I was screening it at a theater in New Jersey. It's picked up by Prime Video, so it's screening publicly in a lot of different places. And so if you get a chance to watch it in theaters, I think it's actually coming to the Air and Space Museum in DC once they fully open up their IMAX theater again after their renovations. So it really kicks you in the pants for some certain moments like launch and everything like that. So it's a fun
Yeah.
piece.
Yeah, I highly recommend people that haven't watched it to get it. It's readily available from different sources. Now, you touched on something I wanted to ask. Are you uh, are you given assignments? In other words, we'd like you to do a documentary on this, or are there times when you say, I want to do a documentary on such and such?
Yeah, this is one that came down as a directive because they wanted us to put this together with this incredible story. I was brought on to do it. But oftentimes we kind of work like a newsroom. We're able to pitch ideas. There are certain things that maybe pique our interest. I'm always in constant dialogue with a lot of our scientists to kind of be up to date with what they're putting out publication wise. And if they have something really fascinating that's about to break or come out, I'll work with them and pitch ideas to our staff to make sure that we have funding for it. We can, properly film it and get everything recorded for distribution. And so it's really cool. There's always new things coming up, and I'm often pitching things and getting stuff put together.
Great. Well, now you have a short trailer you can maybe show
Yeah,
of
sure.
Cosmic. Let's
Yeah,
go
let
and
me
watch that.
put this up. Hopefully you can see this here.
For 25 years, NASA has been filming the journey of the James Webb Space Telescope. This is a never-before-seen look. I'm excited for people to see the drama of what it takes to make a space telescope.
Nature has this way of being even more creative than we are. We have always been surprised by what we see in the sky. That's why building a telescope has always been interesting.
The voyage back to the birth of the universe.
These decades of work of thousands of people around the world to make this telescope possible.
Okay, gonna have lots of inventions along the way.
Now, how can we justify this to our constituents?
We're going to change how we understand the universe.
Science is a process.
All 6 metric tons of this has to be launched 1 million miles out in outer space.
Isn't that kind of crazy not to be able to service it?
And liftoff.
Yeah, that's the only choice we had.
I really wanted to honor what an incredible mission this was.
We were on edge, from blizzards to hurricanes.
There was nothing easy about Webb at all.
Constant pressure.
There was something different about this one. You knew you were in the middle of something big.
We're going to see all the way back to the very beginning of the universe, what we call cosmic dawn.
Yeah, so there you have it, Cosmic Dawn.
Yeah, it's called The Untold Story of the James Webb Space Telescope, and it really is, because our club has seen presentations in the past of the James Webb Telescope and how the mirrors had to fold out and how the insulating layers had to be stretched out below it. And all this had to happen a million miles out in space where nobody could tell it, it could fix anything that didn't work. But what we haven't really seen until we watch this show is all the decades of work that went in to making sure this worked, because you only had one shot. I mean, if this didn't work, there were, as I recall, there were like 344 or something like that critical junctures. Any one of them, you have $1 billion piece of space junk out there.
Exactly.
So what you did was you went back and told the story of how it started, practically a drawing on the back of a napkin, all the way up through the incredible decades of work it took of engineers and testing after testing. So tell us how when you came into it, you had all these archives to work with, correct?
Oh yeah, there's so much footage. It was, I guess, a good problem to have. There was almost too much to work with, but I had to distill it down. Stuff had to be cut. I kind of looked like a madman. I had index cards spread all across the floor of my apartment as I was mapping different story beats out, placing things around. And I want to make sure I was keeping scientifically and historically accurate as I was putting all this together. And there was so much I didn't know even happened until I started doing the research, digging into the archives. There's all these crazy twists and turns. I mean, the mission was almost lost numerous times before it even left the Earth here on the spacecraft, the Ariane 5 rocket. And so there's so much to capture, so many little moments in the archives, and a lot of other things too, external factors like the politics. The mission was almost just flat out canceled multiple times as things came up and didn't work out, and testing caused issues and delays to the launch. And it was a crazy journey. I still kind of can't believe it happened looking back through the archives and all this stuff, but it was a joy to put together. I had a blast stitching all this together, making the edits, and cutting this whole piece together. It really kind of wrote itself, at least in my eyes. It really feels like a Hollywood blockbuster story. It's just this incredible story of human triumph and inventing and doing the impossible and making it a reality. It's a beautiful story. And the ending in particular is really touching. I think watching it back, I'm not going to spoil, there's more to it than just it being successful. There's a lot that goes into it. And I think watching it now with the context of everything that's going on in the current state of the world, it's really a pretty impactful story. And I know a lot of people who we've shown publicly so far, including congressmen yesterday, are really touched by the story and just the amount of effort that goes into it.
Yeah, I couldn't agree more. How long were you working on it?
About a year, which is kind of an insane timeline too. For feature-length films, usually it's a couple of years process. I mean, they've been filming this for about 20, 30 years, so there's a lot of archival footage, but my role started around this time last year, late September, beginning of October. I started scripting things out, moving the pieces around, and then basically lived in our edit booth at Goddard for the better part of the last year, working through, cutting things together, testing stuff. And we actually had a post-production team based in DC that worked on the sound mixing. So if you do watch it in theaters, the sounds are actually mapped to specific speakers and surround sounds. You'll hear it hit you from behind or kind of swish around on the sides for different moments. And they also did the color corrections. So that was about a month or so process to work with them. But yeah, it was a long journey, and a lot of reviews throughout the process. I mean, thousands of people have touched this telescope throughout its journey to get to space. And we had a lot of people review it for accuracy to make sure that we're telling the right story, that the science is accurate. A lot of people on the creative side having input on things too, since this was such a big project for the agency. And then we actually got a distributor that was interested in this film, and they're affiliated with the Tribeca Film Institute and the Alamo Draft House. So they brought the film to theaters that way too on Prime Video. So yeah, it was a huge production, and it was kind of a wild experience being right in the center of it all. I'm, I guess, fairly new to this stuff. I mean, I've been working at NASA for about 6 years, but this was a huge project, and I was definitely up for the challenge, and I had a blast working on it.
Did I hear you say you also did the music for it?
I did, yeah. I've got a music background. I play violin. I've played it my whole life since I was maybe 4 or 5 years old, and I always really loved the sound design and music and films. And I listened back through a lot of different music as I was making things. I've actually had a couple artists outside of NASA. I do a lot of freelance production work for musicians, making artwork for their albums and concert visuals. And Trent Reznor from Nine Inch Nails, who's done a number of really fantastic scores for movies like The Social Network and Pixar's Soul, had actually reached out to me and sent me some of his unreleased music to play around with. We weren't able to use it for this film, but it was really cool for me on a creative side to kind of break down his process, listen to his music, how he kind of structures things, puts things together. And I used a lot of that inspiration as I was actually crafting my own music, this kind of industrial, mechanical, driving kind of music that I made for this piece. So it was a blast. And I really learned a lot through that process too. I had not done that amount of music production for a piece like this before. Usually it's these 2 to 3 minute long videos, but the whole piece, it was a huge effort to put all that together.
Well, that's amazing. Now, some of the choke points you mentioned, there were many times in the history of the James Webb when it almost stopped. It almost was killed. One particularly suspenseful moment, you touched on it, was, and the preview kind of vaguely mentions it, is tell us about the time when Hurricane Harvey almost put an end to the whole thing.
Yeah, so in 2017, the telescope was doing testing in Chamber A at the Johnson Space Center in Houston. It was doing this cryo testing where they brought it down to very cold temperatures. It sat there for a couple months, and it had to stay at those temperatures. They had to really slowly cool it down and really slowly warm it back up, because any huge flux in temperature could break pieces of the hardware. That's just, you don't really want to expose something to that quick a temperature change and expect it to hold up. So they had a 5-day supply of liquid nitrogen in case anything went wrong. If there was, the chamber shut down, lost power. They planned for all these contingencies, but one contingency that I guess a lot of our team didn't realize they had to prepare for was hurricanes. Houston often gets battered by a number of hurricanes. It's right in the path of a lot of different storms. And there was a forecast that was coming up for a tropical storm initially that started to kind of increase in intensity to category 3 and then category 4. It made landfall and really battered Houston. And the team made it through it. They got their first measurement of the primary mirrors. They did a selfie of it effectively, where they kind of took a picture of it just to see how things were aligned and get some measurements. They were starting to celebrate that. They're like, we made it through it. We got through this hurricane. It's all good. And then they got a call from the meteorologist that said, hey, we see the storm is actually coming back around, picking up more water from the Gulf, and is about to redump and hit you guys again. And so they actually got battered really hard for a second time, and the storm just sat on top of them for a couple days. The supplier of the liquid nitrogen was underwater, so they couldn't get their shipments. There was water leaking through the ceiling of the building, so they had to put like tarps and covers all over their equipment. There's amazing photos that we actually show in the documentary of a lot of our team members just sitting underneath these like ponchos, basically, working, because they still needed to do work. This telescope was still there, and they almost ran out of liquid nitrogen, which would mean that they'd have to do this rapid warm up and the telescope could be broken. And after all that, they managed to pull enough of the liquid nitrogen together. They finally got a shipment. They survived that. But when they actually opened up the chamber to look at the telescope after they'd warmed it back up again, it was covered in dust. Because this chamber A, the last time it was used was to test the Apollo landers. And that was, about 50 years prior. And so there's all this dust and particulate that just fell onto the mirror of the telescope. And so it's crazy. There's just all these twists and turns. And I mean, it almost, was lost in those moments back in 2017. This is 4 years before it launched, in December of 2021. So that's just one of many instances of craziness that happened to this telescope throughout its long journey that I guess I wasn't necessarily aware of too when I first started going on this. And when we dug into the archives and a lot of our interviews, stories like this just kept coming up. And it's just incredible that it happened, that people, through everything managed to make this telescope a reality. And so it's beautiful. It's an incredible story. And so there's so many of those moments in there that make this. And yeah, it was really fun to edit that sequence.
That was rather a suspenseful moment in the program. You prepare something like this for the harsh rigors of space, and you sometimes you forget that the harsh rigors of Earth can damage your project just as well.
Oh yeah, absolutely. I mean, they also had to think about shipping this thing around the country, around the world. They put it on a massive cargo ship and sent it through the Panama Canal to French Guiana for launch. And there are all kinds of concerns there with pirates tracking it down and maybe getting the telescope. They shipped the mirrors across the country on the back of just a normal truck, a shipping truck, and could have gotten into an accident. We lost the mirrors. There's just so many little details, and the team thought of everything. The 344 single point failures, those were in space, but there's so many moments where the telescope was just, moments from being lost here on Earth. And so, yeah, it's wild.
Yeah, stories I never heard before, such as you mentioned when it was being shipped across the water. There was a blogger or a podcaster or somebody who was keeping track of it and giving people exactly where the ship was carrying the telescope. And NASA had to contact that guy and say, could you be a little vague about where this ship is at? Because, we're afraid pirates might invade it.
Yeah, people are very passionate about tracking the telescope. You can track ships, you can track planes, with these things. So people were tracking the ship, down to very precise locations. And yeah, I mean, it's carrying priceless cargo. And so we didn't want any kind of interruptions or people messing with the shipment as it was going on its way to the launch pad. So yeah, there's just all these little moments. And that was what was so cool about this film, is finding all these moments and crafting together the story. It's just, it keeps you on the edge of your seat, even though it's successful. I think for me, one of the biggest inspirations as I was making this film was another really fantastic documentary from recent years called Free Solo, about Alex Honnold and his free solo attempt of El Capitan in Yosemite. Even though he's successful, just the entire film, you're on the edge of your seat. You're like, is he going to fall? Is he not? So that was kind of the vibe I wanted to go for with this film too, where the mission's out there in space, it's taking beautiful photos, but man, it was close. It was on the brink for the better part of 20 years. And so, yeah.
And one of the things that you also brought out very well, I thought, was every time it's on the brink or there's a problem like this, you've got scientists who have spent their careers, 10, 20 years working on this project. And if it failed, or if Congress said, nah, we don't think we're going to fund it anymore, or the hurricane, breaks the mirror, what they've been working for 10, 20 years is suddenly finished, over, right?
Yeah, exactly. Yeah, this is people's whole careers. It was a make or break for so many people that put in years of their life for this. And, in an instant, it could all go up in air. It was just so close to disaster and so many times. And, they kept their cool and managed to persist through this. And it still kind of blows my mind, the dedication that they had. And I tried to highlight that too in a couple different moments in the film. You'll see how people have kind of aged and really sacrificed a lot of their lives for this telescope to make this a reality.
Yep, and as you pointed out, it has a happy ending. When it launches, you're watching it, yeah,
Yeah,
and
it's
when
triumphant. Yes.
And then when it unfolds and get those first images, I remember in our club we were all excited as soon as those first images were released. I think there were 4 or 5 of them. We featured it on our monthly meeting because they were such incredible photographs. And ever since then, now, even though we're kind of getting blasé about it, just about every week there's new discoveries being made with that incredible instrument.
Oh yeah, big time. Yeah, I was just talking with some folks yesterday that were doing some work with Uranus, finding a new moon there. There's all kinds of other stuff that's coming up. It's just incredible. And you often think of it looking out in the cosmos, but a lot of the work that I do with these scientists is looking inward at our own solar system, looking at moons around Jupiter and Saturn, looking at inward as Mars. We've even observed the DART mission, which was the double asteroid redirect test that impacted an asteroid to try to see if it could redirect its course. We managed to image that with Webb 2 in real time. So just the science is incredible. And the sensitivity is really what's mind-blowing too. It's able to peer through the atmospheres of exoplanets and tease out the chemistry of these faraway worlds and in detail that we just had never really thought was possible before. So it's just mind-blowing.
Yeah, I wanted to ask you about that because one of the other series that you've been involved in for NASA is called Other Worlds. And there was one episode called Other Worlds Titan about Saturn's largest moon. And it was eye-opening to me to realize that even though with Cassini-Huygens, I think, a mission that went out there and flew by Titan several times and did all that even with probes that are out there by the object in the solar system, the James Webb Space Telescope way back here can still provide images and information that even the probes can't get. And that was just amazing to me that James Webb can be used, because we think of it as in terms of, the earliest galaxies and things like that, but it can also look inward at our own solar system, as you say. Incredible usage of it.
It's helping us out with some of these missions that are going there too. Actually, as we speak, there's the Europa Clipper mission zooming to Europa to look at it up close. And, we're kind of supplementing its observations with observations from Webb too, to kind of highlight specific areas on the moon that we want to look up, in closer detail. And yeah, just the sensitivity, like I said, is just incredible. So, I mean, we're just discovering so much about these places that, we yeah, as you mentioned, even up close, we couldn't discover with some of these probes. So it's fantastic. It's beautiful.
And sticking with Titan for a minute,
Yeah.
you're also mentioned a project that's, I think it's still in design, called Dragonfly. And I don't
Correct.
know if it's funded or not, but tell us about Dragonfly, because I thought that was an incredible attempt at engineering.
Yeah, so the main project is actually going to be run out of the Applied Physics Lab at the Johns Hopkins University, so not too far away from your astronomy club. And also Goddard has a big piece of it too, with some of the instrumentation on the spacecraft. But it's really cool. It's this kind of helicopter-looking design. You typically would think of dropping a rover like a Martian rover to kind of explore the surface, but the team figured out that it would be a little bit better to send this copter out there to be able to fly to different regions of interest and power itself and take off and land autonomously and do these measurements and be able to zoom around the surface of it better. So that's still in development. I think it's supposed to launch, just got slightly delayed, but I think it's supposed to launch in the early 2030s. So we've been testing it out in analog sites to kind of see how it would hold up, and it's looking fantastic so far. But that is going to really change our understanding of Titan and be able to look at it up close in that way. With a machine, a device like this too. So really excited about that. And again, learning about Titan with Webb too, we're going to kind of help Dragonfly prepare better to explore this environment up close.
Now, when you have a program like that, you also have animation, a lot of animation involved with it. And I understand that you yourself create a lot of that animation. Is that right?
I do, yeah. I wish we could have GoPro cameras everywhere in space capturing this stuff in real time, but the reality is we unfortunately don't always have cameras everywhere. So I work directly with the scientists as they're getting their raw data back, and I'll work with them to reconstruct what we believe is these atmospheres that we're looking at or what the surface of these worlds looks like. And I've done some pretty cool visualizations over the year. I think the favorite one I put together was for asteroid Bennu. OSIRIS-REx was this asteroid sample return mission. It studied this asteroid about the size of the Empire State Building up close for about a year and a half and mapped it to better resolution than we have our own moon, which is down to 2 centimeter per pixel resolution. So we had this incredible resource of this terrain data, and I actually brought that into a software called Unreal Engine. It's a video game software, but I was able to reconstruct the surface of our sample site, Nightingale, and place you, the viewer, down onto that surface. And if you had a VR goggles or a 360 headset, you could stand and take in the majesty of this surface. And I synced it up in real time with a visualization of the spacecraft as it was landing down to take a sample. We did kind of a narrated piece to guide you through as if you're standing there observing this as it was taking place, unfolding. And that was all based on real telemetry from the spacecraft, its exact trajectory down to the surface, the real terrain data from Nightingale on Bennu. And it was just fantastic. So I love doing stuff like that. I've done some more stylized pieces too. Oftentimes we're given kind of the green light to, stretch a little bit more. There's a whole cartoon series for kids that I made for this Lucy mission that's studying the Trojan asteroids. I did a Spider-Verse style comic book animation for a Mars mission called Maven that's studying the ionosphere of Mars. It made a really fantastic discovery of these things called sporadic E layers. We have them here at Earth. They actually bounce your radio signal off these little pieces of plasma, high density regions in the atmosphere here on Earth. And we're trying to better understand them on Earth. They're hard to predict here on Earth, but on Mars, they're very predictable in predictable locations. So Maven's been studying them, and I made this kind of stylized comic book animation based on the real data that we're getting back, a little bit stylized, obviously, but still true to the science that's going on. So again, every project's different, and I always kind of pitch some crazy ideas at times, and I'm always happy when the scientists are receptive to what I put forth to make these things a reality. And it's always a fun exercise putting them together in the animations.
Yeah. Now, where did you pick up animation as one of your tool sets?
Yeah, this is something I've been doing for a while. Actually, it goes back to when I first got into film back in middle school. I used to make Lego stop motion animations with my Star Wars Lego sets. I'd put them together and have them animate. And then as I got into college or high school and college, I did a lot of science fair projects where I would do animations, 3D models. My research in college was a lot of computational modeling, working with the Geophysical Fluid Dynamics Lab as part of the Atmospheric Administration, NOAA. And so I would do these 3D animations of tropical cyclones, and I did maps of earthquakes and the subsurface of Earth, doing animations of that. And so kind of picked up a little bit more of the technical skills of animation over the years, kind of how these things go together, how you design the physics engines, the render engines for a lot of these things. And, the art kind of followed. Art is science, science is art. They're very intertwined. And I've always tried to keep the two very intertwined in my life as I go through. And a lot of it I've just picked up on the job, talking with these scientists. We've got a really fantastic visualization studio at Goddard. And I often will just pick their brain over lunch of how they work with their different render software. And a lot of them have backgrounds working for places like Pixar, where they've developed these render engines and for real-time rendering and for really fantastic animations. And so I'll just ask them a ton of questions and practice. And outside of the NASA work, like I mentioned, I do a lot of these concert visuals, but I also do animations for different companies and things. And I've had my work displayed on the Sphere in Las Vegas. I've done projects for the Met Gala up in New York last year for Porsche, the car company. I've done a variety of different things. And so I'm always trying to learn new things, and then I apply those skills to a lot of my NASA projects too, which is always really fun.
Well, you also do some fun little things, such as you mentioned the asteroid capture Bennu, and
Yes.
you were illustrating the difficulty in making sure that the return capsule hit the atmosphere at exactly the perfect angle. And to illustrate it, you got two NBA stars trying to do half-court shots. I thought that was great.
That's right. Yeah, we did that, and then also prior to that, we did one with the WNBA too, where we had a star from the Washington Mystics team do kind of a similar project. Yeah, we're always looking for kind of funky ways to relate the science back to things that people can kind of understand a little bit more in human scales. We'll often get kind of knocked for this because people always say, "Oh, NASA actually would never use any kind of units. We're always comparing things to like the size of a building or the length of a horse or something like that." But sometimes just saying this thing is 20 meters long, that doesn't really mean much to people if you kind of put that in human scales. For example, for Nightingale, when we landed OSIRIS-REx there, it was kind of landing basically in a parking spot. That was the equivalent of doing that. So you're kind of parallel parking on an asteroid. So when you explain it in those terms to people, you understand the complexity, and doing that a million miles away from us autonomously, navigating hazards on top of it. It's kind of that way of explaining the science in a little bit easier to understand way. You were talking earlier about how the audiences we're trying to reach and having that in mind. And that's always in mind for me, is how can we make this understandable as opposed to just listing off numbers or facts? How can you relate this to the average person? And yeah, it was great to do the little basketball metaphor there. That certainly worked a lot, which is fun.
Now, a couple of other quick questions. We're getting close to our time here, but you also are heavily involved in live events for NASA, launches, things like that, even solar eclipses. I know producing and maybe even being involved in a live event, poses different kinds of challenges, including, I assume, some rather long periods of time when everybody's sitting around waiting for a hold or whatever's going on with the launch. In all your live experiences, is there any one that particularly stands out as being particularly exciting or memorable?
Oh yeah, they're all just super intense and really a lot of fun. We always plan for all the contingencies, everything that could possibly go wrong. But still stuff happens that's unexpected. I think my favorite one that I've ever done was the one for the OSIRIS-REx asteroid sample return mission. It was just such a unique environment. We brought our whole operation out to Utah, actually on the Dugway Proving Grounds. It's an Air Force Army facility. And so we worked directly with the Air Force. They had a bunch of their cadets working with us in their broadcast truck to help stream the broadcast live. So that was really cool learning from them. We had a WB-57 high altitude plane streaming in real time as the samples coming back in. We had helicopters from the Air Force flying out, documenting things. And I, in front of me as a correspondent, had all of these live views to look at as this was happening in real time. And I had to keep my cool, keep calm and collected as I'm watching this happen. And just talking about Webb and how close it was to the brink, this was extremely close to the brink too. I mean, the sample came in through the atmosphere about half as warm as the surface of the sun. It was a ball of plasma. And over the course of about 13 minutes, it slowed down to a measly 10 miles an hour as it landed softly in the Utah desert. And I got to cover it all throughout that process, doing the play-by-play commentary. And it was terrifying. At one point, we didn't know if the parachute had successfully deployed, the drogue chute, to stabilize its descent. So it was kind of in a free spin, and it was giving me memories of what happened many years back in the early 2000s with the Genesis probe that landed in the same exact environment in Utah, but did not deploy successfully as parachutes and smashed into the surface and compromised the pristine nature of these samples. And so we're watching in real time. I had to keep going as I see this thing tumbling and tumbling, and eventually the drogue chute or the parachute's deployed successfully. It was this bright orange creamsicle colored parachute. I still remember seeing it very clearly on my images in front of me. and just the joy I felt, and just this collective sigh I could hear from the production team as everyone was watching this unfold too. And then the subsequent couple hours after that, when we were actually flying out team members from our astrobiology unit in helicopters to retrieve the sample and safely transport it to a mobile clean room we'd set up in the desert where they contained it, and then eventually shipped it on a huge cargo plane, a C-5 plane, down with the Air Force to Johnson Space Center's curation facility. So I was there every step of the way, documenting that live, keeping calm, cool, and collected, keeping you, the viewers, calm, cool, and collected as we were watching this happen unfold in real time. And there was a lot of dead space too as we were waiting for this thing. There's a lot of time it took for people to fly out there on the helicopters, and I just kind of kept going, rattling off a lot of the cool science that was happening in real time that we were preparing for. And I'd done my research beforehand to know what was going on. I researched everything down to the material of the gloves that the team members were wearing, the material of the ablative heat shield that was keeping our sample safe within as it was coming through as a ball of plasma, and all of the amazing science that we were anticipating getting from the sample once we finally cracked it open. So that really stands out to me as one of my favorite broadcasts, I think, of all time. It was just so incredible.
I can see that. Now, I highly recommend for our viewers to go to just Google, NASA Plus as your search, and you'll get to the the NASA Plus website, and where many of your videos are located, and also live events. You can see a listing of all the live events that are coming up, so if you want to watch the next SpaceX crew flight, go there and you can watch it take off live. Here in Florida, of course, we can actually see it sometimes.
It's
taking
awesome. Yeah. It's all free too. All this stuff, NASA Plus. I know there's a lot of streaming services out there. We're one of the rare ones that's actually free. So you can peruse at your leisure. It's all perfectly free for you to download and share. And so this film, the Cosmic Dawn film, is on there. It's also on YouTube too. We're actually at about 750,000 views, I think, already after about a month and a half of it being out there, which is pretty incredible. So definitely encourage you to watch and share our content. It's all there for you.
Okay, great. Well, now on a last question, on a more serious note, has any of the recent budgetary issues coming up in Congress, the cuts that we keep reading about for NASA, what effects have you seen it having?
Unfortunately, massive effects. And this, for me, is one reason why I'm really touring this Cosmic Dawn film around, including, like I said, yesterday's screening for Congress, because it's more important now than ever that we get this funding. And I think people often lose sight of the technical challenges that go on behind closed doors as we're making these missions a reality. You often see the bookends. You see the success or you see the failure, but you don't see the in-between of getting all that stuff together, the incredible work that goes in on the engineering, the technical side of things. And just about a week or two ago, about 4,000 of my team members were let go or took the early retirement buyout package. And so we're really shorthanded. We've lost a lot of team members. There's a huge threat for the next fiscal year of shutting down a bunch of our missions that are currently going on. The one we were just talking about, Dragonfly, another one, Da Vinci, is potentially on the chopping block. That one's going to be visiting Venus like never before with a probe that will descend through the atmosphere and capture some incredible measurements. Even Osiris-Rex is on to an extended mission that wasn't initially intended. We've rebranded it to Osiris Apex because it's visiting something called Apophis. It's an asteroid that's going to be about 1/10 the distance between us and the moon in 2029. We're going to look at it up close, hopefully. But right now it's on the chopping block too. So we've massively scaled back our team. We've lost a lot of team members who've, have been let go or took these buyouts. And so it's very challenging. And NASA is not the only place in government that's been affected by this. We know a lot of our friends over at NOAA and the National Weather Service have also been let go. And it's more important now than ever to have science and have these conversations and do this research and make it happen. And so for me, Cosmic Dawn is very much, for me, a love letter to NASA, to science as a whole, to why we take on these massive international collaborations for the sake of humanity to benefit everyone. And so, that it's been a tough time to say the least, but really trying to persist through this. And the reception we've gotten so far for this film has been fantastic. Everywhere we've shown, people are really engaged and are asking how they can help. And the best way you can help is call your senators, call your congressmen and women, and let them know why this matters to you. Talk about the impact science has in your community. Why you're inspired to to do what you do and you know, share this film out too. It's like I said, a great piece that really documents why we do this science and how important it is to all of us.
That's why what you do is so important, because by getting the message out as to, you know, the wonders that we're uncovering, and the jobs and the engineering and the expertise that we're developing in these projects. You're talking. We talked earlier about who you're talking to. You're talking to voters. You're talking to people that make a difference, that elect those congressmen and senators and presidents. And you know, hopefully, with what you're doing, you know, they can put pressure on their representatives to say, look, don't cut this. Don't cut NASA. You know, keep the funding there. This is important to all of us. So we want to thank you so much for what you do, James. And it's been a real pleasure talking to you. And I'm going to now, we're right on about time. I'm going to turn it back over to Rich and see if, Rich, do you know of questions that people have, or in chat, or maybe somebody can raise their hand if anybody has any questions for James?
I don't see anything in the chat right now. I do know that one question I have to ask, and that is, do you have any productions coming up that we should be watching for?
Yeah, there's a big one that I'm actually working a lot on, doing a lot of interviews for, all about the Artemis missions coming up. We have Artemis 2 set to launch next year. That's the manned astronaut mission that's going to go out past the moon and back. And then Artemis 3 is when we're actually going to be putting boots on the ground to start to establish a sustainable presence on the south pole of the moon, harvesting water ices to use for hydrogen fuel to blast off to Mars and beyond. And so I've been working with our astronaut team members, interviewing them, working with them as they're testing and preparing in analog environments. They've been testing the spacesuits out in places like Iceland, in the desert in Arizona, even underwater. They've been doing some kind of spacewalks off the Florida Keys. There's a really cool facility that they have there where they'll do these spacewalks outside of a vessel to prepare for their eventual deployment on the moon. So that is the next really big feature piece. And then also documenting the Roman telescope as it's nearing completion. It's set to launch next year too. And so that one, like I said, is at Goddard currently. I've been working with a lot of folks there to film and document the preparation as it's going through. It's this amazing wide field observatory that's really just going to blow our minds once it fully gets out there. And then lastly, the one huge mission that's in very early stages that I'm starting to work with some of our science team members on is called the Habitable Worlds Observatory, which its sole purpose, or its main purpose, is to look for habitable worlds, these places that could have life, these exoplanets, making these observations of their atmospheres and studying them in exquisite detail. So that is really exciting too. This is one of the first missions I'm aware of where we're doing something just solely for the purpose of life seeking. So really exciting stuff. So a lot to look forward to if we're funded. That's a big if right now, but a lot of really cool science in the works potentially.
Well, that's quite a load there. So at this point, looking at the audience here, who else has questions for James? Do we have you can unmute yourself and ask away. And I'm looking, and maybe are people able to unmute themselves?
Well, I'll ask a question if that's okay. So, James, you're making all of these incredible videos. Are you working with a group of individuals, or do you do most of the work? How does that work?
Yeah, we're a very small team, so kind of by necessity, we kind of have to do it all. So I work on everything from the scripting, the filming, the editing, even the distribution, the outreach. I'll often go to schools and museums and talk with students and educators about the work we're doing. And we're kind of like the in-house ad agency, if you will, for NASA, kind of marketing the work we do. And, you know, it's a very small team. I'm one of two producers covering all of planetary science for all of NASA. So there's not a lot of folks doing this, and which is cool because we touch it all. We get to really see a lot that's going on. But yeah, by necessity, we kind of have to do it all. So it's always learning new things, which is exciting.
Yeah, thank you.
Yeah.
Okay. All right. Well, at this point, I think we can really thank you. That was a great conversation, and very, very honored to have you on the program. Thank you very much, James. Terry,
Yes.
like to
Yes,
close out the program?
Yeah, thank you very much, James, for being our guest tonight. We will send you, which I'm sure you will treasure, a coffee mug with the emblem of our club, and your name is our guest speaker for August 28th. So
awesome. Thank you so much. That's fantastic.
I expect it to show up in one of your videos. No, just kidding.
Absolutely. Yeah, it'll be behind me here. I can place it up here so it's on display.
And again, thank you so much for agreeing to be here. It's been a fascinating discussion. And again, on behalf of the club, the Alachua Astronomy Club and the Far Out Journal Club, which is a part of it, we thank you so much for being here and giving us your time. And again, everybody should go check out the NASA Plus website and find some really incredible. You can spend days there just browsing through the videos that are available, and plus the upcoming live events. So again, I think we're just about ready to finish. So I will say good night. Thank you to everybody for being here, and have a great week, a great month, and let's keep the funding going for NASA. Thank you very much, James.
Thank you so much. Thanks for having me. This is a blast. If you have any
good.
follow-up questions, feel free to email me. I'm always happy to chat and talk a bit more about this cool stuff.
All right, thank you.
Awesome
job, Mr. Tralie. Thank you.
Thank you.
Okay, that will do it for our evening. So thank you all for being here, and see you next time. Bye-bye.